Welcome to the first of 7 videos covering quadratics at higher maths. The first video, learning intention, is to do a recap of National 5 quadratics knowledge. Some of the topics you would have covered in National 5, I will go into more detail at higher, so they will have their own video, but some of the concepts behind them I may cover in this kind of intro video, kind of recapping what you previously knew. So some concepts will go in depth here, some will be covered in further depth later down the line, given their significance within the higher course for them. So this is a recap. It's going to be an overview. Well, first and foremost, an equation of the form y equals ax squared plus bx plus c is called a quadratic equation. It's the level up from a straight line, and in the form y equals ax squared plus bx plus c is known as the standard form of a quadratic. So, for example, a graph of the form y equals ax squared, x squared minus 3x minus 4 would look the following. Key facts that you can take away from that: it has a turning point at 3/2 25 quarters. I'm not going to go into how that's worked out, but except that's the case. Hopefully you can see from the grid markings that is the case for this one. The points where it crosses the x-axis are known as the roots of the equation. Important kind of concept. It was used a lot at National 5, and again, those concepts are important within higher. It has an axis symmetry at the turning point. That will be useful. That concept, again, can help you find coordinates at turning points, roots, things like that. So again, that concept needs to be at your back of your mind whenever you're dealing with quadratics. And number 4, the turning point is always halfway between the roots. Now, at higher, quadratic skills and knowledge will be used a lot, and I mean a lot. There are a lot of questions, other topics that will use quadratic skills in order to be able to solve them. So be prepared to use quadratics. That means your understanding from National 5 can't be, I just kind of got by with it. It needs to be solid. It needs to be sound. It needs to be, you fully get all the concepts covered at National 5, because we're going to use them, and we're now going to use them within other contexts within the higher course. And remember, on many occasions, a quadratic question will be part of something else. So it won't be just a quadratic question on its own. So you've got to know when to apply the quadratic knowledge and when to use it successfully, or how to use it successfully. So when the x squared term is positive within any quadratic, you will always have a minimum turning point. That, to me, I refer to very simply as the happy face, as example below. And when the x squared term is negative, e.g. minus 2x squared plus 6x plus 8, you will always have a maximum turning point in the sad face. Again, this is important when you see the equation for a quadratic, and you need to learn to pick up on those things, because that will guide you on whatever the quadratic is doing, the solutions it's going to give, and therefore the effect it will have on whatever context you're applying it in. Now, quadratic equations at National 5, we learned 3 different forms. I've already given you the first, the standard form. In this form, it's useful for finding the y-intercept. It will just be the value that the plus c is. So it'll have a y-intercept of 0c. It'll tell you whether it's a min or a max turning point by the positive or negative x squared term. The second type is factorized form. That's where it's already been turned into factorized form, if it can be factorized. When in this form, that allows us to find the roots, which is also important for solving. So that's a big aspect, and again, will be a big aspect at higher. And you can tell from it a min or max. If both x terms are positive, you've got a minimum, and if one of the x terms is negative, you will have a maximum. Completing the square form, I've added the a at the front. You want to deal with that at National 5, but we're going to go in more detail at higher. So you have plus or minus a bracket x plus or minus p squared plus or minus q. In this form, you can find the turning point. Remember, the turning point's x coordinate will always be opposite in sign to what is inside the bracket in the square form. Q is just whatever value it is. You can't tell whether it's a min or max. It depends. If there's a negative outside the bracket, it's a maximum. If there's no negative, it's a minimum. And another key thing of the completing the square form, allows you to find the value of the max or min, depending on what type 1 you have. If you have a maximum turning point in completing the square form, you can find the maximum value. If you have a minimum, you can find the minimum value. It will be whatever value plus or minus q is. So that's kind of important, but that will be covered in more detail in one of the other videos. Quadratic formula, quick recap. Some quadratic equations of the form ax squared plus bx can't be factorized. Some, technically, the vast majority of quadratic equations that exist can't be factorized. However, there are a way of finding the roots in those scenarios, and that can be the quadratic formula, which was learned in National 5 and was given. The quadratic must be in its standard form and equal to 0 for this to be used. No, this formula would work for all quadratics, but we would use factorizing method where possible, so it's quicker. Now, at higher, it's very, very rare for the quadratic formula to be used. I struggle to recall if it ever has been used. It's potential that it has in the old papers going back to the 80s and 90s, but recently I struggle to give an example. That might not be the case, but I struggle to recall. But I'm telling you now, we're in a new higher. This is something that could throw your way in one of the questions. So just have it in the back of your mind that it could happen. The discriminant, again, this topic we'll cover in more depth in a separate video, but just as an overview, what is the discriminant? Well, it's the b squared minus 4ac. Very important part, and I'm telling you now, you're going to use the discriminant a lot within higher maths, and it's an important concept for higher and beyond. It comes from the quadratic formula, the square root part, and it's very useful for identifying whether a quadratic has two roots, equal roots, or no real roots. When b squared minus 4ac is greater than 0, it will have two real and distinct roots. In the formula, that means it can be square rooted, and will therefore give a plus and a minus, which changes and gives you the two different x coordinates. So that's the type of quadratics you're looking at. When b squared minus 4ac equals 0, you have equal real roots. That means you have one root. That means your parabola, whether it be max or min, is just sitting on the x-axis. It's just touching it, not cutting. And when b squared minus 4ac is less than 0, you have no real roots. And important, the word real, if you go beyond higher, you'll learn the significance of why we say real, but you've not to worry about that higher. That means the parabola never crosses the x-axis, whether it be max or min. And our concept you covered, what was it, in the National 5 course? Again, we weren't 100% sure that the SQA would consider this National 5, so it is covered. So this goes in a grey area, because it did used to be in the higher course, quite distinctly, because I've got past paper questions. But more recently, given the revamp, I suspect it's a National 5 concept, but worth paying attention to here and learning. So you can be asked to find the equation of the quadratic using the to find the equation of the quadratic, use the form y equals k bracket x plus or minus a. So factorized form with a constant outside. If the question came out, it's likely they will give you that and tell you to find the values for k, a, and b. To do that, you'll be given the following information. You'll be told the coordinates of the roots. You have to be. There's no other way of doing it. And you'll be given one other coordinate in the parabola. That is not a root. So, example. Determine the equation of the quadratic in the form y equals k bracket x plus minus a, x plus minus b, if it has roots at minus 4, 0, and 1, 0, and also passes through the point 0, 4. Well, first and foremost, you substitute the x coordinate of the roots into a and b in the given equation just correctly. Watch out when you sub in, remember the x coordinate will be opposite in sign for a and b. So a will be 4 and b would be minus 1. Since the root is positive 1, it would be minus 1 within the factorized form. And if it's positive, if it's minus 4 as the root, it would be positive 4 within the equation. So that gives us, at this point, y equals k bracket x plus 4, x minus 1. To find k, we use the other coordinate we're given. You'll always be given that, so you substitute the other coordinate into the new equation and rearrange to find k. So we were given 0, 4, sub it in, allows you to rearrange and find k. You cannot sub one of the roots in, one of the turning points, or the roots, because when you sub it in, it's going to lead to 0 as one of your points, because your y value would be 0. So it doesn't allow you to find k because you'll be multiplying by 0. Subbing in the root value allows you to find that the value of k should have equal minus 1, so you can then write the full equation. Or you could write it without the minus 1. You don't have to write the 1 part, just the negative value needs to be outside, which you could also multiply into the equation. So there is 2 or 3 different ways you could give that as a successful answer. Example 2. As I said, past paper, the old higher, this was considered a higher level topic and occurred relatively frequently. So we're in this grey area. I think it is in National 5, but in theory it could still play a part, maybe part A of a bigger question within a higher topic. So this question diagram shows part of the graph, gives you the form, gives you the information and don't list it, they give it in the diagram. So again, go through, sub in the coordinates of the roots. Be careful. It's positive 4, positive 1, so that'll be -4, -1. Just watch how they give the equation up at the start of the equation, because there could be wee subtle ways they try to catch you out. But just know it should be x minus 4 because it becomes a positive 4 root and it becomes a positive 1. Subbing the other coordinate in allows you to find the coordinates you need. So rearrange, it allows you to find k, simplify, rearrange to make k the subject, and you find that k equals 3. Rewrite the equation, because it says what the equation in the graph, rewrite it in its full form. Now, this is likely to be the type that you might get at higher, where there's a bit of thinking and there's letters involved. So they may take a National 5 skill, but just ask it in a slightly more technical way at higher. So again, this is why I've picked it. It comes from the 2001 higher paper 2. Right, the diagram shows a sketch of the parabola passing through -1, 0, 0p and p0. So they list the coordinates. So sometimes they do, sometimes they don't. Show that the equation of the parabola is this. So they've actually asked for it. They want it in an expanded form. They're not telling you to use the factorized, but I'm telling you from experience, use the factorized form and get back to the standard form that they've given it there as a final step. So write in the, the roots, which you've been given, even though they're letters. Well, one of them is a letter. Watch out, it's positive p, so it'll be x minus p, and it's -1, so it'll be x plus 1. Sub in the other coordinate they give. Again, it can involve a letter. Don't be scared. That just means, you have to deal with it. And in this case, it turns out that the p cancels and leaves a actual value of -1. But k could have been a letter as well. Don't be intimidated by the use of letters. That's part of your algebra skill. Now we have the equation, multiply it out. So that means multiplying out the two brackets, then multiplying through by the -1. When you do that, you're going to get quite close to what they've got there. But what they've done is factorized any terms with x in it. So factorize the middle two terms, taking x out as common factor, which leaves p plus p minus 1 bracket x minus x squared. So watch out. That's a good level question. Go back to 2001. Good skills. That's potentially one that you could be asked in your exam. Solving a quadratic equation. This was big. This is a big topic. Very unlikely that you would have done a National 5 paper without some form of solving. So in this example, solving a quadratic equation involves finding the roots, i.e. the x-coordinate of where it crosses the x-axis. To find the roots, the quadratic must be in its standard form and equal to 0. That means it's ax squared plus bx plus c equals 0. Roots occur when y equals 0, so that's why it must be the y equals 0. And I've said before, to use an equation to solve, you always rearrange it in that form, and the solution in that form will answer whatever question you asked first. We'll cover more of that with some of the examples. At higher, a quadratic will nearly always be solved by factorizing. Very unlikely the quadratic formula will be used. I have shown an example, but again, very unlikely. Example 1, solve the following. Well, it's already equal to 0, so you just factorize using whatever method you see fit. This is my method, but again, the method you use is irrelevant as long as you factorize correctly. And I would like you to get to a point where hopefully you don't need to use a method. You can just put the brackets in, and by trial and error within your head, you can make sure you pick the right values. But feel free to stick to a method if you know it works. Solving each one, we get x equals 1 and 2x equals -5, so x equals -5 over 2. There are two solutions. That's it. Solved. Find the roots of the following quadratic equation. Again, just be prepared for negatives. Equate it to 0, be able to factorize when there's a negative in front of the x squared term. Again, whatever method, feel free to do it. When you solve it, as long as you get the correct solutions, I don't care what method you use, you should have got x equals -3 over 2 and x equals 2/3. Third example. So it's asking you to find the roots, but this is also asking you to determine the turning point of the quadratic. So find the roots. It's already by equating to 0 because the roots occur when y equals 0. Factorize by whatever method. Solve for each factor at this point. But we've been asked to determine the turning point. Now, a key fact I mentioned back in the review, your turning point is always halfway. The x-coordinate of the turning point is always halfway between the two roots that you have, if you have roots. So we can find the x value by just doing a kind of what value lies halfway between -3 and 1? Well, that is x equals -1. We then sub that into our equation, either the factorized form or the original, to find the y coordinate, thus giving a turning point of -1, -4. So again, using our skills of knowledge about the roots and the turning point. Example 4, it's just where they don't, you're asked where does x squared equal 3x plus 10. We'll cover more on this, but that involves rearranging, equating to 0, and then factorising. This new quadratic, x squared minus 3x minus 10, will have roots that will give the solution of when x squared does equal 3x plus 10. So that's the beauty of the mathematics, the skill, and the kind of wonder of what it's able to do. So factorising again, solving for each root, you have x equals 5 and x equals minus 2 will be the 2 points when the x squared will equal 3x plus 10. You can check it, sub the numbers in, left will equal right. Solve the following. Again, that can start out, it doesn't look anything like a quadratic, but we have an x term on the bottom of the fraction, we multiply that out, that gives us x squared plus 3 equals 4x, and that will give us, so basically, this will create a quadratic whose roots will answer the question, when does x plus 3 over x equal 4? So it can start off nothing like a quadratic, but a bit of legitimate mathematical manipulation, it can become, a quadratic, because its solutions, there is only 2 possible answers, therefore it gives a quadratic, because a quadratic can have a maximum of 2 roots. So solving gives x minus 1 and x minus 3, so x equals 1 or x equals. Example 6, again, this is taken from the past paper, credit level, I suspect. Since it says give your answers correct to 1 decimal place, that is your warning that it won't be factorizable. So you need to use a quadratic formula, use A, B, C. A is 2, B is 3, C is minus 7. Must be in standard form to use it. Recall minus B plus or minus square root of B squared minus 4AC over 2A. Sub everything in, watch for double negatives. Watch for, what was it, the minus in front of the b, and then do your 2 solutions, and you should have got x equals 1.3 and x equals